The Northrop P-61 Black Widow is a twin-engined United States Army Air Force fighter aircraft of World War II. It was the first operational U.S. warplane designed as a night fighter, and the first aircraft designed specifically as a night fighter. Created by Northrop Aviation in collaboration with the British Royal Air Force, the P-61 was also the first aircraft designed to use radar. With its mysterious appearance and name, the Black Widow ruled the night in the waning months of World War II. When World War II began, the U.S. Army Corps and the British Royal Air Force flew mostly outdated aircraft compared to the war-ready counterparts on the Axis side. In August 1940, 16 months before the United States entered the war, the U.S. Air Officer in London, Lieutenant General Delos C. Emmons, was briefed on British research and radar, which had been underway since 1935 and had played an important role in the nation's defense against the Luftwaffe during the Battle of Britain. General Emmons was informed of a new airborne radar, AI for short, a self-contained unit that could be installed in aircraft and operated independently of ground stations. In September 1940, Tazard mission traded British research, including the cavity magnetron, that would make self-contained interception radar installations practicable for American production. Simultaneously, the British Purchasing Commission, evaluating U.S. aircraft, declared their urgent need for a high-altitude, high-speed aircraft to intercept the Luftwaffe bombers attacking London at night. Night fighters would soon become their own category of aircraft. A night fighter, or all-weather interceptor, was a fighter concept. Still, it wasn't until after the catastrophic bombing raids over Europe, particularly the London Blitz in 1940, that the military air force has really found a need for a plane catering specifically to these types of missions. The Northrop Aircraft Corporation, located in California, had only been in active operation since 1939, mainly as a subcontractor for larger aircraft manufacturers. It was definitely an unlikely candidate to develop the world's first night fighter. More prominent corporations such as Lockheed, Grumman, and Douglas were already committed beyond their capacity, stocking America's existing aircraft fleet. Northrop availability gave it a window of opportunity. On the 5th of November, Northrop and Pavleka met at Wright Field with Air Materiel Command officers and presented them with Northrop's preliminary design. The Douglas XA-26A night fighter proposal was the only competition. Northrop's design was selected. Following the USAAC acceptance, Northrop began a comprehensive design work on what would become the first dedicated night fighter. The result was the largest Pursuit-class aircraft flown by the U.S. during the war. The aircraft was huge, as Northrop had anticipated. While far larger and heavier multi-engine bombers existed, its 45.5 feet or 14-meter length, 66-foot or 20-meter wingspan, and projected 22,600 pounds or 10,251 kilo full load weight were unheard for a fighter, making the P-61 hard for many to accept as a feasible fighter aircraft. Some alternate design features were investigated before finalization. Late in November 1940, Jack Northrop returned to the crew of 3 and twin-tail rudder assembly. To meet the USAAC's request for more firepower, designers abandoned the ventral turret and mounted 4 20mm Hispano M2 cannons in the wings. As the design evolved, the cannons were repositioned in the belly of the aircraft. The P-61 therefore became one of the few US-designed fighter aircraft to have a quartet of 20mm cannon along with the NA-91 version of the Mustang and the US Navy's operated F-4U-1C Corsair as factory standard in World War II. Following a few small changes, Northrop's NS-8A fulfilled the USAAC's requirements, and the Air Corps issued Northrop a letter of authority for purchase on December 17th. A contract for 2 prototypes and 2 scale models to be used for wind tunnel testing was awarded on the 10th of January 1941. Northrop's Specification 8A became, by designation of the War Department, the XP-61. Northrop's engineers built a full-scale wooden mock-up of the XP-61. So, on March 10th, Another contract was approved by the Undersecretary of War for $5 and $1.5 million. This ensured the production of 13 YP-61s, and the groundwork was laid for the production of the airframes that would become the famous P-61 Black Widows. It was also a rather large aircraft for a fighter, at 50 feet long and a wingspan of 66 feet. The P-61 was a twin-boom design with a crew consisting of a pilot, gunner, and a new member, a radar operator. He would operate the compact airborne interceptor specifically designed to fit inside an aircraft, leaving out the middleman who had previously relied on instructions from radar-operated out-of-ground stations. The production model of the SCR-720A mounted a scanning radio transmitter in the aircraft nose. In airborne intercept mode, it had a range of nearly 5 miles, or 8 kilometers. The unit also functioned as an airborne beacon or homing device, navigational aid, or in concert with interrogator responder units. The XP-61's radar operator located targets on his scope and steered the unit to track them, vectoring and steering the pilot to the radar target via oral instruction and correction. Once within range, the pilot used a smaller scope integrated into the main instrument panel to track and close on the target. This rotating 30-inch scanner receiver dish antenna would sweep the sky with a knife-like beam. When used, it reduced the ground echoes that plagued long-wave radars at low altitude. This shorter wavelength enhanced accuracy, betting interceptors within just 100 yards of intruders in total darkness. His radical shift was the main reason that the Black Widow could fly at night, as the device allowed pilots to navigate and locate airborne enemies in real time. Red-colored cockpit lighting was another innovation that further aided the vision and night fighting. The Black Widow's lethal bite could rival any that the enemy had to offer. It was armed with 4 20mm Hispano M2 forward-firing cannons mounted in the lower fuselage and 4 50 caliber M2 Browning machine guns lined up horizontally with the 2 middle guns slightly offset upwards in a remotely aimed dorsally mounted turret. A similar arrangement to that used in the B-29 Superfortress using 4-gun upper-forward remote turrets. The XP-61's spine-mounted dorsal remote turret, driven by the General Electric gyroscopic fire control computer, could be aimed and fired by the gunner or radar operator, who both had aiming control and gyroscopic collimator sighting posts attached to their swiveling seats, or could be locked forward to be fired by the pilot in addition to the 20mm cannon. The radar operator could rotate the turret to engage targets behind the aircraft. Capable of a full 360 rotation and 90-degree elevation, the turret could be used to engage any target in the hemisphere, above and to the sides of the XP-61. The unique system was to often have difficulty achieving an accurate aim. The P-61 was powered by 2 Pratt & Whitney R2800 double Wasp radial engines, each packing 2,000 horsepower. The 2 engines were each mounted approximately 1/6 out on the wingspan. It was capable of a maximum speed of 366 miles an hour, which was relatively fast considering its immense size. The P-61 also had an internal fuel capacity of 646 gallons. Its estimated fighting weight was over 29,000 pounds. Main landing gear bays were located at the bottom of each nacelle, directly behind the engine. Each engine cowling and nacelle drew back into tail booms that terminated upward in large vertical stabilizers, and their component rudders, each of a similar shape to a rounded right triangle. The horizontal stabilizer extended between the inner surfaces of the 2 vertical stabilizers and was approximately 3/4 the chord of the wing root, including the elevator. The elevator spanned approximately 1/3 of the horizontal stabilizer's width, and, in overhead plan view, angled inwards in the horizontal from both corners of the leading edge towards the triangle edge approximately 15 degrees, forming the elevator into a wide, short trapezoid. Leading edge updraft carburetor intakes were present on the wing shoulder and the root of the outer wing, with a few inches of separation from the engine nacelle itself. Thin horizontal rectangles with the ends rounded out to nearly a half circle, with multiple vertical vanes inside of it to direct the air stream properly. The main fuselage was centered on the aircraft's centerline. It was, from the tip of the nose to the end of the plexiglass tail cone, approximately 5/6 the length of one wing. The nose housed an evolved form of the Signal Corps radar SCR-268, the Western Electric Company's SCR-720A. Immediately behind the radar was the multi-framed greenhouse canopy, featuring two distinct levels, one for the pilot and a second for the gunner above him and behind him, the latter elevated by approximately 6 inches or 150 millimeters. The forward canopy in the XP-61 featured contiguous, smooth-curved, blown plexiglass canopy sections facing forward, in front of the pilot and the gunner. Beneath the forward crew compartment was the nose gear wheel well, through which the pilot and gunner entered and exited the aircraft. The radar's operator station was at the aft end of the gondola. The radar operator controlled the radar set and viewed its display scopes from the isolated rear compartment, which he entered by the way of a small hatch with a built-in ladder on the underside of the aircraft. The overall design was exceptionally clean and fluid, as the aircraft possessed very few sharp corners or edges. Another stealthy innovation was the new glossy black paint in the metal armor instead of the usual olive green and gray paint. Like flight tests in Florida in October 1943 pitted both schemes against each other, the black color was not detached in 80% of flights throughout the gauntlet of anti-aircraft searchlights. Starting in February 1944, all Black Widows were painted deep black, allowing the P-61 to truly fit its name. It took Northrop engineers over a year and a half to fix developmental delays and revisions. They have no problem getting the crews of volunteers to the training. Redesigns during the production phase cost Northrop 2 critical wartime years, although its late rollout and obsolescence will ultimately be its demise. The Black Widow delay is turned into a platform for innovation. The P-61's official public debut was quite dramatic. In January 1944, AA-61 performed a nighttime flyover of the Los Angeles Coliseum, filled with 75,000 attendees as part of a new Army-Navy show. According to some accounts, the crowd couldn't see the plane and could only hear its engines passing over. The first squadron to fly the Black Widow in Europe was the 422nd Night Fighter Squadron on May 23, 1944. Almost a month later, the 425th Squadron received their Black Widows. However, both of them received the aircraft too late to participate in the D-Day invasion on June 6. The first P-61 engagement in European theater occurred on the 15th of July, when a P-61 piloted by Lieutenant Hermann Ernst was directed to intercept a V-1 flying bomb. Diving from above and behind to match the V-1's 350-mile-an-hour speed, the P-61's plastic rear cone imploded under pressure and the attack was aborted. The tail cones failed on several P-61A models before this problem was corrected. On the 16th of July, Lieutenant Ernst was again directed to attack a V-1, and, this time, was successful, giving the 422nd NFS in the European theater its first P-61 kill. The absence of turrets and gunners in most European theater P-61s presented several unique challenges. The 422nd NFS kept its radar operator in the rear compartment, meaning the pilot had no visual contact with the operator. As a result, several pilots continued flying their critically damaged P-61s under the mistaken belief that the radar operator was injured and unconscious, when in fact he had already bailed out. The 425th NFS moved the radar operator to the gunner's position behind the pilot. This provided an extra set of eyes up front and moved the aircraft's center of gravity about 15 inches or 380 millimeters forward, changing the flight characteristics from slightly nose up to slightly nose down, which improved the P-61's overall performance. By December 1944, P-61s of the 422nd and 425th NFS were helping to repel the German offensive known as the Battle of the Bulge, with 2 flying cover over the town of Bastogne. Pilots of the 422nd and 425th NFS switched their tactics from night flighting to daylight ground attack, strafing German supply lines and railroads. The P-61's 420mm cannon proved effective in destroying German locomotives and trucks. During this battle, the P-61 obsolescence became apparent. Lieutenant van Nisvander was piloting his Daisy May Black Widow when an encounter with the twin-engine Messerschmitt 410 led to a pursuit across the top of the woods. This wonder attempted to attack and follow its enemy by chasing it at full throttle, but by the time the Black Widow caught up, The ME-410 pulled away at 400 miles an hour, making the P-61 seem painfully slow in comparison. The 422nd and 425th Squadrons also found themselves critically short of spare parts by the end of 1944. Being a smaller company, Northrop couldn't keep up with the demand and supply issue was never corrected. The squadron had made do with whatever equipment they had on hand. Most operational 61s ended up being sent to the Pacific. After Guadalcanal was secured in late 1942, the American stronghold urgently needed nighttime protection from Japanese nighttime raids launched out of bases in the surrounding areas. The Black Widows weren't ready yet, so the Americans temporarily adapted B-25s, P-40s, P-38s, and P-70s as night fighters. Finally, in May 1944, the Black Widows were ready to fly in the Pacific. The first to receive a P-61 was the 6th Night Fighter Squadron. They were the only night fighting squadron until the 418th and 419th Squadrons also began working with Black Widows. On July 1, 1944, the 421st Squadron was also activated, and operating from bases at Nadzab, New Guinea, and Wake Island. Actual fighting by the P-61 was sparse. The 418th Squadron, based on the island of Morotai in the Hull, Maharas, and the Duchious Indies, operate at the top, scoring Black Widow. Highlighting the P-61 light action in combat, the 418th conducted a mere 18 successful attacks. Its most triumphant mission came when the 3 Kawasaki Ki-61s were destroyed in a single night. Despite its innovative design, the P-61 was only able to play a minor role during the last 6 months of World War II. The Axis towers were already too weak to put up much of a fight on the ground, let alone in the air. The Lady in the Dark 61, piloted by Captain Lee Kendall, is perhaps the best-known Black Widow in the world. The fighter was photographed hundreds of times in the Pacific theater. It was also the aircraft that presumably scored all the final 2 aerial kills of World War II. The first kill happened on the night of the war, and the second one almost an entire day after all battles had officially ended. Captain Kendall took down Japanese Imperial Army aircraft in kamikaze missions by aggressively pursuing them and causing them to crash on their own. The P-61 proved capable against all Japanese aircraft it encountered, but saw too few of them to make any significant difference in the Pacific War effort. Simply put, the 61 arrived too late to World War II. Although it was useful in battles against the Japanese Air Force, it was already obsolete in Europe by the time it got there. Northrop engineers tried to fix as many issues forced by the P-61 as possible. She redesigned the airborne intercept radar and improved the remote control turret. Turbochargers were also added to the aircraft, but it still lagged in speed. Despite his late arrival, Black Widow still saw combat in every theater of World War II. The fighter destroyed a total of 127 enemy aircraft and 18 German V-1 buzz bombs. The useful life of the Black Widow was extended for a few years into the immediate post-war period due to the USAAF's problems in developing a useful jet-powered night/all-weather fighter. Shortly after the war, a Black Widow was used in early American ejection seat experiments. The P-61 was heavily involved in the Thunderstorm project from 1946 to 1949, a landmark effort to gather data on thunderstorm activity. The project was a joint effort by 4 U.S. government agencies, the U.S. Weather Bureau and the NACA, assisted by the U.S. Army Air Forces and Navy. Scientists from several universities also helped the launch, design, and conduct of the project, which aimed to learn more about thunderstorms and how to better protect civil and military airplanes from them. The P-61's radar and particular flight characteristics enabled it to find and penetrate the most turbulent regions of the storm, and returned crew and instruments intact for detailed study. Surviving aircraft were offered to civilian governmental agencies, or declared surplus and offered for sale on the commercial market. 5 were eventually issued civil registrations. The P-61 was, in fact, a remarkable response to the mission set for it, but that mission had already changed before it got into combat. Northrop, a small manufacturer that rose to meet the challenge, did an amazing job of building a sophisticated, new technology airplane that had no precedent. They didn't adapt an earlier design to become a night fighter or base the P-61 on anything that already existed. They started with a clean sheet of paper and invented the first all-weather day-night interceptor. In that sense, it was the beginning of today's anytime, anywhere 24-hour US Air Force. It was the start of something else big, too. Oddball specialty airframer Northrop aircraft, one small enough that it could be given the night fighter assignment without disturbing the work of such long-gone industry giants as Republic and North American, is today, as the Northrop Grumman Corporation, the 5th largest defense contractor in the world.
This is the P-61, called the Black Widow. She's well named because she packs 4 caliber 50 machine guns and 4 20mm cannon. An obituary notice goes with each bite. Those twin engines will carry her fast enough to catch up with almost anything in the sky. And she's maneuverable, as a fighter should be. Very easy to handle. She stalls, takes off, and lands at low speeds. Getting checked out on her is a pleasure. The Black Widow flies the skies in 3 sleek models. First, the YP-61, the earliest model of this ebony killer. Then the P-61A, the first model to go into combat service. And finally, the P-61B, the newest combat version. Let's watch this pilot learning his stuff on a P-61A. The first thing to do is familiarize yourself with the cockpit. Learn where all the controls and gauges are located. The TO for the airplane is a big help. Diagrams and photographs make it easy for you to get to know the ship. After a couple of hours of study, you are able to pick out the controls and gauges without the loss of a second. And with your eyes shut. That's important because you can't afford to waste time in this fast twin-engine job. And there's no co-pilot around to help you. You're going up for a ride, just to get the feel of the ship. But first you have to check the airplane, thoroughly. That's your best guarantee for living to a ripe old age. Like most airplanes equipped with tricycle landing gear, the 61 has a nose gear towing pin. Check it, as the nose wheel may shimmy on takeoff and become damaged. Check the nose wheel pin cap. Be sure it's on tight. Then check the rest of the landing gear for inflation of the tire and general condition. The red mark shows whether the tire has slipped on the rim. The strut ought to be extended about 4 inches. And another item not to be forgotten is the pressure in the emergency landing gear system. There's a gauge in each wheel well. It should show 700 pounds per square inch for the nose gear. Repeat the same inspection on the other 2 wheels. No cuts or bruises. Tread's okay. No slippage. Strut clean and extended around 4 inches. And the emergency pressure? 750 pounds per square inch for the main landing gear. Now to give the exterior of the plane a general going over. Skin's all right. No loose rivets or dents. Antenna mounted securely. De-icer boots okay. No rips or places where oil or gasoline has been spilled. Gun bay doors tight. Control surfaces in good shape. All hatches and doors must be closed and locked. Otherwise, they'll blow open and probably off when the plane's in the air. So each one should be checked. The radar operator's top hatch, rear entrance door. Now you can get into the cockpit, but you have to climb right out again through the top hatch. Careful not to step on any plexiglass. There's one thing more to check outside the airplane. The gas tank filler caps. Two on each side, and oil cap. Make sure they're fastened tightly in place. Here's an old story, but a wise one. Form 1A. Check and sign for red diagonals. Turn on the circuit breakers behind the gunner's seat. And make sure the gunner's escape hatch is closed and locked. From now on, you are in command of the airplane. What would you do now? Well, you know the answer to that from studying the tech order. Turn on the generators, then more circuit breakers, the ones for the starters and fuel booster pumps, and the light circuit breakers. Now look around the cockpit to see if everything is in order. Nothing loose. No tools or papers to foul up the controls. Instruments okay. The controls, and that includes the throttles, are locked. Unlock and try them out. Operate the rudders, elevators. Put ailerons through their complete range. Notice that those ailerons are unusual? They're the spoiler type, especially effective at high speeds. The P-61 is the only airplane in the Army Air Forces that has them. Controls are all okay. See if all the controls and switches are set properly. Open throttles 1/4 to 1/3. Prop control switches in automatic. Feathering switches normal. Test the prop circuit breakers to make sure the buttons are in. Check fuel in all tanks. Fuel valves set to outboard tanks. Crossfeed, which supplies both engines from one tank, off. Air pressure for the emergency brakes ought to be 425 to 450 pounds per square inch. Check the clock against your watch and the altimeter. Oxygen pressure 425 pounds per square inch. Oxygen regulator to auto mix on. Test the trim tabs. If they're in good working order, set them for takeoff. Now the instructor is ready to take over. While the ground crew pulls props through 12 blades, set the superchargers at neutral. And throttles 1/4 to 1/3 open. Adjust both mixture controls to idle cutoff. Props at full increase RPM. Check to see that the props are clear. Then turn on the battery switches. On the P-61A, there are 2 individual battery switches and a master battery switch. The master switch on the ignition unit is for ignition only. Turn booster pumps to low. Carburetor air cold. Oil shutters 1/3 open. Make sure all cowl flaps are open and the intercooler flaps closed. Automatic pilot oil pressure off. Make sure that the VHF switches are off. Check carburetor air filter. Turn on master ignition switch and the right switch to both. Energize the starter and then prime the engine in the last 5 seconds of energizing. Since a putt-putt is furnishing your power, you should energize for no longer than 10 seconds before flipping the switch to mesh. If you are using the battery, the maximum energizing period would be 20 seconds. Don't energize beyond those limits or you'll damage the starter. When the putt-putt is being used, only your main battery switch should be on. Turn on the other switches when the crew chief disconnects the putt-putt. Adjust your mixture control to auto-rich. Close the throttle to run your engine as slowly as possible until oil pressure is indicated. As soon as oil pressure shows, adjust to between 1,000 and 1,200 RPM to prevent fouling of the plugs as a consequence of prolonged idling. Now we're ready to run through the same procedure for the left engine. Throttle to between 600 and 700 RPM until the oil pressure gauges indicate a steady pressure. The cold oil pressure will go up to 150 or 200 pounds until the oil temperature gets to 40 or 50 degrees centigrade. Keep the prop governor in high RPM. Turn the fuel booster pumps off. Your fuel pressure should be between 15 and 17 pounds. When the oil temperature gets to about 40 degrees centigrade, open the oil cooler flaps about 1/3. Keep the engine cowl flaps open. Operate the cowl flaps and intercooler flaps, watching them from the window. Operate the oil cooler flaps and check the gauge. Check both hydraulic pressure gauges. Make your interphone check and see that all entrance hatches are closed and locked.
Okay to taxi to runway 29. Use taxi strip directly in front of you.
Runway 29, roger.
Use brakes for taxiing as little as possible. This holds good for any two-engined airplane. And when you want to turn, use your outboard engine. Always taxi with your flaps up. Set brakes and proceed to make check. Your oil pressure should be at normal, and cylinder head temperature must be over 100 degrees. Now check one engine at a time. See that the prop is at high RPM, and put mixture control in auto rich. Open your throttle briefly to about 40 inches to clean the engine out. Then, reduce manifold pressure to 30 inches. RPM should be from 1950 to 2100. Check your ammeter. It ought to show charge. Next, turn off one magneto. Your loss of RPM should not exceed 100. Now make a quick check on the other mag. Running an engine at high manifold pressure on one mag may cause serious detonation. Next, test the prop circuit breakers. Pull the prop governor control lever back from its high RPM setting until it drops 200. Advance the prop control to the original setting. Use the feather switch to check the prop. When RPM starts to drop, switch back to normal position. Put the prop selector switch in decrease. As soon as RPM drops 200, move the switch to increase. When the RPM goes back to 2100, put the switch in automatic. Now go through the same procedure for the other engine. And then you're ready for the final check. Fuel booster pumps at high. Fuel pressure between 15 and 19 pounds per square inch. Prop circuit breakers down. Prop switches at automatic. Prop controls at high RPM. Mixture auto rich. Intercooler flaps closed, upper cowl flaps closed, lower cowl flaps open about 1/4. Wing flaps 1/3 down. Gyro instruments uncaged. Oil temperature should be between 40 and 90 degrees centigrade. The oil pressure 75 to 90 pounds per square inch at 2,000 RPM. Cylinder heads between 120 to 205 degrees centigrade. Hydraulic and accumulator pressure 800 to 1100 pounds per square inch. Now you're ready to scramble. Yes, the P-61A takes off like a homesick angel. But flying the P-61B is smoother and even more efficient, with these latest modifications giving her top performance. A rack for night binoculars, a new wrinkle in night fighting, an electrically operated accessory panel, push-button type circuit breakers, 2 improved heating units, trim tab removed from aileron, landing gear with a neutral position. In the down position, a lock prevents the gear from being raised accidentally. Main gear nacelle doors close with wheels down. Taxi lights on the nose wheel. Now let's go upstairs and watch another P-61 go through its paces. A YP in this case. The ship takes off at about 105 miles an hour, indicated without flaps. She'll fly herself off the ground. But now let's see how the P-61 takes off with flaps. Using quarter flaps provides another normal takeoff. Notice that the nose need be raised very little. But if you ever have to take off from a bombed field in a hurry, use 2/3 flaps. Keep nose wheel on ground until you have flying speed, then pull her loose. Climb a few feet and level off to gain speed. The P-61 will take off in a short space if you handle her correctly. Here's another way to clear an obstacle at the end of the runway. Flaps down 2/3 again. But this time, stay on the ground as long as possible, gaining all the speed you can. Then pull up steeply and keep climbing until the obstacle is cleared. 140 miles per hour gives you the best rate of climb, but 160 is generally recommended for normal operation. The higher speed keeps the engine running cooler. For normal cruising, use 2230 RPM or less. Manifold pressure, 29 to 34.5 inches in auto lean. Oil temperature, 60 to 85 degrees centigrade. Oil pressure, 60 to 90 pounds per square inch. Fuel pressure, 15 to 17 pounds per square inch. Cylinder head temperature, about 210 degrees centigrade. Generator voltage, 28 to 28.5. Amps, 200 maximum each when using turret and all radio equipment. Shift the supercharger every 3 hours to prevent accumulation of sludge. The Widow is very easy to get along with. She won't give you any trouble on turns. Climbs like a monkey. Dives well. Here she is doing a chandelle. A stall at about 95 miles per hour with flaps up and power off. The response and effectiveness of elevator and rudders is completely normal. Elevator forces are exceptionally light for a ship of its size due to the spring-loaded tabs. Failure of either engine in flight isn't a problem if you follow the proper procedure. Hit the feathering switch, then close the throttle. Move the mixture control to idle cutoff. Turn the fuel supply of the dead engine off. Snap the ignition switch off after the prop stops rotating. Put the live engine in auto rich. And trim your rudder tab. Close the cowl flaps on the dead engine all the way. And finally, close the oil cooler flaps and intercooler shutter on the dead engine. Even when stalled on one engine, the Black Widow isn't in trouble. On one engine, you can turn in either direction if you maintain safe single-engine airspeed, have your plane trimmed properly, and remember coordination. And don't be timid about racking her around. You can even do vertical banks into the dead engine if you keep her at proper flying speed. To unfeather is equally simple. Turn the ignition switch on with the throttle closed. Set the prop control lever to the decrease RPM position. Turn on the fuel supply. Move the mixture control to auto rich. Set the feathering switch to normal position and hold the selector switch in the increase RPM until your engine speed reaches 800 RPM. Then release the selector switch. When minimum engine operating temperatures have been reached, place selector switches in automatic. And finally, adjust mixture, throttle, and prop levers to the desired power and engine RPM and retrim the ship. In case of both fuel and booster pump failure on one of the engines, turn on cross-feed valve and the booster pump of the operating engine to high.
If, in an emergency, you need the absolute maximum performance, use the water injection, which is found on most P-61s. Just shove the throttles all the way open. That turns on the pumps. And then push the water injection switch. That sends the water into the engine.
To use the autopilot, turn on the pressure valve. Pressure should be between 100 and 125 pounds per square inch. Trim the ship so it'll fly hands off. Uncage the gyro pilot instruments. Line up the control indices. First the rudder. Then the aileron. And last, the elevator. Set the speed valve at 2 or 3. Now turn on the autopilot. And finally, if necessary, readjust the indices for level flight. Well, I guess we've been up long enough. Let's head for the barn. Turn the autopilot and cockpit heaters off. Check to see that de-icer and anti-icer are off. Turret stowed. Fuel to fullest tank. Cross-feed valve off. Mixture auto-rich. Fuel booster pumps high. Supercharger neutral. When airspeed drops below 175, lower gear and check it. Hydraulic and accumulator pressure, 800 to 1,100 pounds per square inch. Props, automatic and set for 2,400 RPM. And lower your flaps. Retrim the elevators. Check brake pressure with your toe. Approach at not less than 110 miles an hour. Touchdown at about 90 miles an hour. Tail down. That was a landing with 3/4 flaps. Let's go back and look at some other types. If you want to use less runway, for example, just lower the flaps all the way. Remember, you have a lot more drag with full flaps, so come in with a little more power. The P-61 was designed with a large area of flaps for slow landings at night. If you're forced to land on a short runway, make a power approach. Use full flaps and fly the airplane quite slowly. You'll have to keep considerable power to prevent stalling, but the ship will get down in less than 1,000 feet this way. For a single-engine landing, bank into the good engine if practicable when you enter the traffic pattern. Lower the wheels just after you turn into the approach, but don't lower the flaps until you're sure of making the field. Use some power on the good engine. Try to make your approach as normal as possible. If you're going faster than normal, fly the plane onto the ground and use the brakes rather than holding it off to lose the excess speed. Some pilots prefer to make a landing with no power. It may be done with full flaps. The glide must be quite steep in order to maintain airspeed, and the flare should be started rather high so the plane won't mush into the ground. But now let's see what happens after the wheels are on the ground. Hold the nose off the ground as long as possible in order to spare the brakes. After you complete the landing run and come to a stop, be sure the cowl flaps are open and raise the wing flaps. Idle the engines at 1,000 to 1,200 RPM until cylinder head temperatures drop below 205 degrees centigrade. Mixture should be auto-rich, and all cowl flaps open. Advance throttle to 25 inches and pull her back, cleaning out the engine. Now move the mixture to idle cutoff and advance throttles to full open as the engines die. Turn off all switches. Hold brakes until chocks are under each wheel, then release. Finally, lock the controls. Well, that ends your first lesson in learning how to fly the Black Widow. You have a long way yet to go, but it's usually a case of love at first flight. She's that kind of an airplane. The Black Widow is designed to kill. The fury of her guns and the flaming wrecks of her victims are lighting up dark skies over enemy strongholds. To you who will fly her at night in hard-hitting air battles, we say good luck and good hunting.